From cold, inhospitable deserts to molten hot lava planets, the universe is filled with all kinds of objects, and for millennia, we've been looking up in the sky and wondering what those objects could be. Even now, in the 21st century, even with our rich interconnection and knowledge available, we still wonder and long to explore more of the universe. Over the eons, we've created amazing tools to help in our search, and another tool to help us has just been launched into outer space, the James Webb Telescope. So let's start talking about this telescope and explaining as to why this telescope matters in our search across the cosmos. Welcome to Space TechnoX, and today we discuss the hype around the James Webb Telescope and why this telescope might be the next big thing in our exploration of the cosmos. Looking at the picture of the telescope itself, with a dimension of 22 meters by 12 meters, or 69.5 feet by 46.5 feet, and half as big as a 737 aircraft, this is no small observatory.
Yes.
Now that we know a bit more about its size as a brief intro, let's discuss the telescope more in detail, or more specifically, the design. First up, the design. Remembering the picture of the telescope, it looks kinda weird, doesn't it? Well, if we compare this telescope to probably the most famous telescope ever, the Hubble telescope, we see some clear differences. Besides the obvious difference of the designs and size, Webb also has far more mirrors than Hubble. While Hubble has two very powerful mirrors, Webb has 18 mirrors. If we were able to get images such as these and these from Hubble, imagine what photos we could get from Webb. The light which they absorb and study is also slightly different. A photo here shows the various spectrums of light. Hubble covers light from ultraviolet to visible on the spectrum, while even though Webb doesn't cover ultraviolet, it'll cover infrared, something which Hubble was able to do but on a limited capacity. It is important observing this type of light because this enables us to see extremely distant galaxies whose light is only visible through that medium. Quick note here. While it may seem that James Webb will replace Hubble, that is not the case. Hubble and Webb will work together, but on slightly different things. Hubble will continue looking into ultraviolet and visible spectrums, while Webb will focus into infrared type of light. That's why it contains far more mirrors than Hubble, because Webb deals with fainter light, so it needs more sensitive instruments to pick that up. Let's now discuss the next thing which makes James Webb slightly different, its image quality. Probably the most important thing in a telescope the size of Webb would be its image quality. If we research and investigate this deeper, the image quality will be similar, yet completely different. Similar because James Webb will take slightly clearer images than Hubble, although the difference will be barely noticeable than Hubble. The main difference, however, will be that Webb is capturing an infrared light, which we already discussed earlier, which will show images in a way we've never seen before. Another key difference is the mirrors on Webb. While Hubble can capture infrared images, Hubble's range is only from 200 nanometers to 2.4 microns. Webb's range, however, will be from 600 nanometers to 28 microns. So, although Webb is designed to capture mainly infrared images, but since visible light falls within 700 nanometers to 400 nanometers, Webb can also capture visible light photos, just like Hubble. Yet, while all this info may not seem useful, these tools and specs will allow us to dig deeper into infrared light. Hubble scratched the surface of infrared, and Webb will go much, much deeper and help us to observe galaxies from billions of years ago. If you enjoyed, please consider subscribing and leaving a comment down below with your thoughts on the video. If you would like to see some other content, some videos are up here. Thanks once again for watching, and see you soon!